Ever wondered whether space itself is stretching while you sleep, or why whole galaxies race away faster than light can chase them? Tonight on Science and Slumber, we'll explore the puzzles that science hasn't cracked: the nature of dark energy, the mystery of time before the Big Bang, and the riddle of life beyond Earth. Settle in and let curiosity meet calm as we explore these unsolved wonders. We gaze out into the night sky and see them as islands of light, but one of the most fundamental questions that remains unanswered is how galaxies, the great star cities of the cosmos, first came into being. The leading idea is that after the universe began, invisible dark matter started to clump together under its own gravity, creating immense unseen scaffolds. These dense regions acted as cosmic wells, pulling in surrounding clouds of hydrogen and helium gas. Over immense stretches of time, this gas cooled, condensed, and ignited into the first stars, which then gathered into small, infant galaxies. These early galaxies then merged and collided repeatedly, growing larger and more complex over billions of years. However, our most powerful telescopes have revealed surprisingly massive and well-structured galaxies in the very dawn of time, existing far earlier than this slow, bottom-up model should allow. It's like finding a towering ancient cathedral that was somehow built in a single day. The universe, it seems, knew how to assemble its grandest structures with an astonishing speed that defies our current understanding, leaving us to wonder what powerful, unseen force shaped our cosmic home. Gazing up at the familiar arrangement of our planets, it feels natural to wonder if our solar system is a common blueprint for cosmic families, but we simply do not know if our planetary arrangement is unique. For centuries, we could only study our own 9 planets, but with the discovery of thousands of exoplanets orbiting distant stars, we have found a bewildering pot, the variety of systems that look nothing like ours. We found hot Jupiters, gas giants orbiting scorchingly close to their stars, and super-Earths far larger than our own terrestrial world. Many of these alien systems are arranged in strange, unstable orbits, a stark contrast to the stable, nearly circular paths of our own planets, with small rocky worlds near the Sun and large gas giants farther out. Finding another solar system like ours, with its specific architecture that may have been crucial for life to arise on Earth, is like searching an endless forest for a specific type of tree you once saw in your backyard. So far, every tree you find is of a bizarre and unfamiliar species. This cosmic uncertainty leaves us suspended between 2 profound possibilities. Either we are a common and unremarkable family of worlds, or we are a rare and precious anomaly in the silent expanse of the universe. We live within a universe that appears exquisitely tuned for existence, leading to the profound question of whether it could have been any other way. The very laws of physics, from the strength of gravity to the charge of an electron, possess values that fall within an incredibly narrow range that allows for complexity, structure, and ultimately, life. If any of these fundamental constants were even minutely different, stars would not ignite, galaxies would not form, and the atoms that make up our bodies would never have held together. It is as if the cosmos is a delicate recipe with dozens of ingredients measured to an impossible precision. Change the amount of just one ingredient by a single grain of salt, and the entire magnificent creation would collapse into an inert and empty void. We are therefore left to wonder if our universe is just one successful outcome among an infinite number of failed cosmic experiments, or if its perfect calibration points to a deeper, undiscovered principle governing all of reality. Among the deepest and most poetic of all cosmic mysteries is the idea that the universe might be experiencing itself through consciousness. This philosophical and scientific question proposes that we are not merely observers looking in from the outside, but rather an integral part of the universe's own process of self-discovery. The same atoms that forge stars and galaxies have, through the long, slow dance of cosmic evolution, assembled into beings capable of wonder, inquiry, and awareness. From this perspective, every question we ask about the cosmos, every telescope we point toward the heavens, and every equation we write to describe reality is the universe itself becoming aware of its own intricate design and boundless beauty. This idea paints a picture where consciousness is not an accidental byproduct of chemistry, but a fundamental feature through which the universe gains a voice. It is as if the universe were a vast, unplayed symphony, existing as silent potential until conscious minds emerge to finally listen to its magnificent music. In this profound and humbling view, we are the living instruments through which the cosmos can finally hear its own song. The very first moment of our universe, the event we call the Big Bang, remains the ultimate cosmic mystery, for we have absolutely no understanding of what caused it. Our entire framework of physics, from Einstein's relativity to the laws of quantum mechanics, can describe with remarkable accuracy what happened a fraction of a second after the universe began to expand, but at the very instant of creation, all our science breaks down. At this point, known as a singularity, all the matter and energy of the cosmos was compressed into a point of infinite density and temperature, a state so extreme that the concepts of time and space as we know them cease to have meaning. It is like tracing a river back to its source, only to discover that it emerges from a point that has no origin, a spring from which all of reality flows, but whose own beginning is completely hidden from view. We are left to wonder if our entire existence sprang forth from a random quantum fluctuation, the collision of other dimensions, or a cause that is forever beyond the reach of scientific inquiry, reminding us that the story of our universe has a beginning that we may never be able to read. Just as we ponder its mysterious beginning, the ultimate fate of the universe remains one of the most profound unanswered questions, with several possible endings to the cosmic story. The future of everything depends on a cosmic tug-of-war between the relentless, outward push of dark energy, which accelerates the expansion of space, and the inward pull of gravity, which tries to bring everything back together. If dark energy continues to dominate, the universe will expand forever, growing colder and emptier until the last stars burn out, leaving a desolate expanse of darkness in a scenario known as the Big Freeze. Alternatively, if dark energy weakens or gravity proves stronger, the expansion could one day halt and reverse, pulling all of creation back into an unimaginably hot and dense state. A fiery finale called the Big Crunch. A more violent possibility, the Big Rip, suggests that dark energy might grow so powerful that it tears apart everything, from galaxies and stars to the very atoms themselves. Choosing between these fates is like watching a single, flickering candle in an infinite darkness. We do not know if it will slowly gutter out, be snuffed by an unseen force, or suddenly erupt in a final, brilliant flash. Billions of years from now, the cosmos will face a destiny that is written in forces we are only just beginning to comprehend. Albert Einstein's theories of relativity are the bedrock of modern physics, yet one of the most significant questions in science today is whether his revolutionary ideas were ultimately incomplete, or perhaps even wrong. His theory of general relativity perfectly describes the universe on the grandest scales, governing the graceful dance of planets, stars, and galaxies. However, it breaks down in the chaotic subatomic realm ruled by quantum mechanics. These two pillars of physics are fundamentally incompatible. Their equations clash, refusing to unite into a single cohesive theory of everything. Furthermore, the very existence of mysterious forces like dark energy and unseen dark matter, which together make up 95% of the cosmos, suggests that Einstein's description of gravity might not be the full story. Relying on Einstein's physics is like having two flawless yet separate maps to navigate the world, one for the vast continents and oceans, and another for the individual houses on a single street. Both are perfect in their own domain, but they are written in different languages and cannot be joined, leaving the complete picture tantalizingly out of reach. The search for cracks in his magnificent theories is therefore a profound journey to discover an even deeper and more unified vision of the cosmos. Of all the questions the cosmos poses, perhaps the most personal and profound is whether we are alone. Our own galaxy, the Milky Way, contains billions of planets orbiting their stars within the so-called habitable zone, a temperate region where liquid water, the cradle of life as we know it, could pool on a rocky surface. Statistically, it feels as though the universe should be teeming with life. Yet, as we scan the heavens with our radio telescopes, listening for any sign of intelligent communication, all we have ever heard is a profound and unbroken silence. This cosmic quiet is the heart of the great mystery, a paradox that deepens with every new world we discover. Our search is like standing in a vast and ancient library with trillions of books, yet finding that every single page is blank, with no story written but our own. The discovery of even a single microbe on a distant moon would ignite a revolution in our understanding, forever confirming that the spark of life is not unique to our small blue world. One of the most humbling discoveries in modern astronomy is that we have no idea what 95% of the universe is actually made of. Everything we can see and touch, the stars, the galaxies, the planets, and ourselves is composed of ordinary matter, which accounts for a mere 5% of the cosmic inventory. The remaining vast majority is made of two invisible and mysterious substances. About 27% is dark matter, an unseen gravitational scaffolding that holds galaxies together, preventing them from flying apart as they spin. The rest, a staggering 68%, is dark energy, an even more enigmatic force that is woven into the fabric of space itself, causing the universe to expand at an ever-accelerating rate. It is as if you were standing on the shore at night, seeing only the glittering foam on the crest of a few waves, while completely unaware of the vast, dark, and deep ocean that makes up nearly the entirety of the world before you. Our entire perception of reality, everything we have ever known or studied, is merely a footnote to a cosmic story whose main characters remain complete and utter strangers. At the heart of nearly every large galaxy, including our own Milky Way, lurks a supermassive black hole, a gravitational monster, millions or even billions of times the mass of our Sunday. Yet, how these cosmic titans formed so quickly in the early universe remains one of the greatest unsolved puzzles in astrophysics. We have observed these behemoths existing when the cosmos was just a fraction of its current age, far too early for them to have grown by the slow, steady process of consuming individual stars and gas clouds. Scientists are divided between two main possibilities. One theory suggests they started as smaller, stellar mass black holes that underwent a period of impossibly rapid growth, somehow feasting on vast amounts of matter. Another, more dramatic idea, proposes that they were born this way, from the direct collapse of colossal clouds of primordial gas, skipping the star phase entirely. Discovering these ancient giants is like finding a fully grown 1,000-year-old redwood tree in a forest that was planted only a decade ago. This mystery suggests that the young universe had a secret and astonishingly efficient recipe for creating its most massive and enigmatic objects, a process that our current understanding of physics cannot yet explain. The existence of our universe hinges on a profound cosmic imbalance that we cannot explain, the simple fact that there is more matter than its ghostly twin, antimatter. Our best theories of the Big Bang predict that matter and antimatter should have been created in perfectly equal amounts. When these two opposites meet, they annihilate each other in a pure burst of energy, leaving nothing behind. If the universe had followed this rule, all the matter and antimatter would have cancelled each other out in the first moments of creation, resulting in an empty cosmos filled only with light. And yet, here we are. This means that for every billion pairs of matter and antimatter particles, there was one extra particle of matter that survived. It is like starting a cosmic game with 1 billion red marbles and 1,000,000,001 blue marbles. After they all collide and vanish, that one leftover blue marble is all that remains. Our entire universe, every star, every planet, and every living being is made from that tiny, unexplained surplus, making our very existence the grandest cosmic leftover imaginable. The greatest mystery in cosmology today might be the invisible force that is pushing our universe apart at an ever-increasing speed, a phenomenon we call dark energy. For most of the 20th century, we believed the universe's expansion, which began with the Big Bang, was gradually slowing down, held back by the collective gravity of all the matter within it. However, observations of distant supernovae revealed a stunning truth. The expansion is not slowing down at all, but accelerating. To explain this cosmic surprise, scientists proposed the existence of a mysterious, repulsive energy woven into the very fabric of space itself. This dark energy acts like a constant, gentle pressure, pushing everything away from everything else. It is as if you are watching a grand cosmic ballet where you expect the dancers to slowly draw closer for a final bow, but instead, an unseen force begins pushing them apart, faster and faster, until they are flung into the infinite darkness. This force, which makes up nearly 70% of the universe, dictates the ultimate fate of our cosmos, yet its true nature remains a profound and unsettling enigma. Of all the concepts we take for granted, the true nature of time itself is perhaps the most bewildering and least understood aspect of our universe. We experience time as a relentless one-way arrow, a river carrying us from a fixed past toward an unknown future. Yet, in the world of physics, time is far more mysterious. According to Einstein's relativity, time is woven together with space into a single, flexible fabric that can be warped and stretched by gravity, meaning that time can pass at different rates throughout the cosmos. At the quantum level, however, time behaves more like a rigid, unmoving backdrop against which the dance of particles plays out. This profound contradiction leaves us with a startling possibility. Our perception of time's flow might be a grand illusion. It's as if we are reading a book, experiencing the story one page at a time, which gives the impression of a narrative unfolding. But the entire book, from the first word to the last, already exists as a complete and static object. We are left with the profound question of whether we are truly moving through time, or if our consciousness is simply moving through a particle universe where every moment already exists, forever frozen in place. One of the most staggering and unproven ideas in modern physics is that our universe may not be the only one, but instead just a single member of a vast, perhaps infinite, collection of universes known as the multiverse. This is not mere speculation, but a possibility that arises naturally from some of our leading scientific theories, including cosmic inflation and string theory. The theory of eternal inflation, for instance, suggests that the explosive event that created our cosmos was not a one-time occurrence, but a continuous process that is constantly spawning new bubble universes, each potentially with its own unique laws of physics and fundamental constants. This concept is like the foam that forms on the surface of a churning ocean. Our entire observable universe, with its billions of galaxies, would be just one tiny bubble in an endless, ever-expanding sea of cosmic foam, with countless other universes constantly popping into existence all around us. The possibility of a multiverse transforms our perception of reality, suggesting that our entire cosmos might be just one page in an infinite library of cosmic stories. Flooding the cosmos in unimaginable numbers, neutrinos are ghostly fundamental particles that pass through nearly everything, yet their most basic properties remain a profound mystery. Trillions of these ethereal particles, born in the fiery heart of our sun and in distant exploding stars, stream through your body every single second, yet you feel nothing because they almost never interact with matter. For decades we thought they had no mass at all, but we now know they possess a tiny amount, though we have not yet been able to measure it precisely. This discovery has huge implications for our understanding of the cosmos, as these countless particles, even with their minuscule individual masses, could collectively account for a significant portion of the universe's total mass. Trying to study a neutrino is like attempting to weigh a whisper or catch a shadow. It is an almost intangible presence that slips through our most sophisticated detectors unnoticed. Unlocking the secrets of this phantom particle could rewrite our understanding of physics and reveal how the universe came to be filled with something rather than nothing. Our planet is continuously showered by cosmic rays, particles from deep space that strike our atmosphere with energies that dwarf anything humans can create, and we have no idea what is accelerating them to such incredible speeds. These are not rays of light, but rather individual atomic nuclei, mostly protons, that have been launched across the cosmos with near light-speed velocity. The most powerful of these particles carry millions of times more energy than the particles in our most advanced accelerators, like the Large Hadron Collider. We suspect that lower-energy cosmic rays are born in the shockwaves of exploding stars, but the origin of the highest-energy ones remains a complete mystery, as they must be created in the most violent and energetic events the universe has to offer. Trying to comprehend their power is like imagining a single grain of sand hitting you with the force of a bowling ball dropped from a skyscraper. The sheer concentration of energy into something so small is almost impossible to fathom. These phantom messengers from the void are a constant reminder that the universe contains natural engines of unimaginable power, capable of feats of acceleration that we are not yet able to explain. While we can observe the contents of the universe, one of the grandest unanswered questions is about the shape of the container itself, the geometry of space-time on the largest possible scale. Our best observations suggest that the universe is almost perfectly flat, meaning that if you travelled in a straight line, you would continue on that path forever without returning to your starting point. However, two other possibilities exist. The universe could be closed, like the surface of a giant four-dimensional sphere, where a long enough journey in one direction would eventually bring you back to where you began. Or it could be open, shaped like an infinite cosmic saddle that curves away in all directions. The answer depends on the total amount of matter and energy in the cosmos. Imagine drawing a triangle that spans billions of light years. In a flat universe, its angles would add up to exactly 180 degrees, just as they do on a sheet of paper. In a closed universe, they would add up to more, while in an open one, they would add up to less. This single, vast geometric property dictates the ultimate fate of our cosmos, telling us whether it will expand forever or one day fall back in on itself. Our familiar reality of three spatial dimensions may be an illusion, as some of our most advanced theories suggest that the universe is woven from many extra, hidden dimensions we can never perceive. This idea is not science fiction, but a core prediction of string theory, which proposes that the fundamental building blocks of reality are tiny, vibrating strings. For the mathematics of this theory to work, it requires the existence of at least 10 spatial dimensions. Some scientists believe these hidden dimensions could explain why gravity is so much weaker than the other fundamental forces, as its influence might be diluted by spreading across all dimensions. Imagine a tightrope stretched high in the air. From a great distance it appears as a simple one-dimensional line. But for a tiny ant walking upon it, the rope has a second dimension, its circumference, allowing the ant to move around it as well as along it. In the same way, these extra dimensions could be curled up into unimaginably small shapes, forever hidden from our large-scale perception. The possibility remains that our entire cosmos is just a sliver of a much larger, more complex reality, a vast unseen architecture just beyond the limits of our senses. One of the most tantalizing mysteries in modern astronomy is the origin of fast radio bursts, unimaginably powerful flashes of energy from deep space that blaze for only a millisecond before vanishing without a trace. These are not flashes of visible light, but intense pulses of radio waves that travel for billions of years to reach our telescopes. In that fleeting instant, a single burst can release more energy than our sun produces in an entire day. Some of these signals repeat from the same location, deepening the puzzle, while others appear to be cataclysmic one-time events. Scientists have proposed a range of explanations, from the collapse of bizarre, highly magnetized stars called magnetars to even more exotic and unproven cosmic phenomena. Discovering one of these is like being on a dark, silent ocean at night and suddenly seeing a single, brilliant flash of light from a lighthouse on a shore you didn't know existed. It is impossibly bright and gone before you can even be sure of what you saw. These fleeting cosmic whispers could be the death cries of exotic stars, or something else entirely, reminding us that the universe can still speak in a language we have not yet learned to understand. One of the most profound puzzles in cosmology is the astonishing uniformity of the universe on its grandest scales. When we look at the faint afterglow of the Big Bang, the cosmic microwave background, we find it has the exact same temperature in every direction, to a precision of 1 part in 100,000. This incredible smoothness presents a deep paradox, because according to the known speed of light, opposite ends of our observable universe have never been in contact. In the nearly 14 billion years since the cosmos began, there simply has not been enough time for any energy or information to travel from one distant horizon to the other, to even out any temperature differences. It is as if you prepared 2 cups of coffee, placed them on opposite sides of a vast continent, and discovered that they had cooled to the exact same temperature, down to the tiniest fraction of a degree, without any possible connection between them. This eerie temperature agreement suggests that the entire cosmos we see today was once connected in an unimaginably small space, and that some unknown event in the first flicker of creation stretched this uniform state across the heavens, setting the stage for the serene and orderly universe we now inhabit. At the heart of a black hole lies the ultimate unknown, a place where the laws of physics as we know them cease to exist. Once an object crosses the event horizon, the one-way door from which nothing, not even light, can escape, its fate becomes a complete mystery. Einstein's theory of general relativity predicts that all the matter is crushed into a singularity, an infinitely dense point with zero volume. However, the laws of quantum mechanics insist that such an infinite compression is impossible, creating a profound paradox at the intersection of our 2 most successful theories of reality. Our current understanding of physics is like a flawless map of a great flowing river, a map that allows us to predict its currents and follow its path with perfect accuracy. But at the event horizon, the river suddenly plunges over an infinite waterfall, and our map simply ends with the words, "Here be dragons." Whatever truly lies within these cosmic abysses represents not just an unknown destination, but a fundamental limit to our quest to read the complete story of the cosmos. One of the most mind-bending mysteries in all of science is how quantum entanglement creates an instantaneous connection between 2 particles, no matter how vast the distance separating them. When 2 particles are entangled, they become linked in a way that their fates are intertwined. If you measure a property of one particle, such as its spin, you instantly know the corresponding property of its partner, even if that partner is on the other side of the galaxy. This connection happens faster than the speed of light, a phenomenon that Albert Einstein famously called spooky action at a distance, because it seems to violate the cosmic speed limit. It's like having a pair of magical coins. If you flip yours and it lands on heads, you know with absolute certainty that your friend's coin, light years away, has just landed on tails. You didn't send a signal, and you couldn't predict the outcome in advance, but the link between them is perfect and immediate. This strange and instantaneous cosmic conversation hints at a deeper, hidden layer of reality where our familiar concepts of space and distance simply do not apply. Our entire understanding of the cosmos is built upon the assumption that the fundamental constants of nature, such as the speed of light and the strength of gravity, have been the same for all of time and in all places. And yet, We have no absolute proof that this is true. These constants are the unchangeable numbers in the equations that describe our universe, but what if they are not truly constant? Some theories suggest that these values could have been different in the early universe, or that they might even vary slightly from one region of space to another. Even a minuscule change in these values would have profound consequences, altering the very structure of atoms, the brightness of stars, and the formation of galaxies. It is as if the universe is a grand symphony, with the fundamental constants representing the tuning of each instrument. We assume the tuning has been perfect and unchanging for 14 billion years, but if even one note has subtly shifted over time, the entire cosmic composition would be different. This unsettling possibility reminds us that our most basic assumptions about the unchanging nature of reality may be built on a foundation that is not as solid as we believe. The vast majority of matter in our universe is an invisible, ghostly substance known as dark matter, and we have absolutely no idea what it island. We know it exists not because we can detect it directly, but because we can see its profound gravitational influence on everything we can see. Without this unseen mass, galaxies would spin themselves apart, their stars flung into the cosmic void. It acts as a vast, invisible scaffolding, a gravitational glue that provides the structure for the cosmos, allowing galaxies to form and clusters of galaxies to hold together over billions of years. Imagine holding a beautiful, intricate snow globe. You can see the glittering snowflakes swirling inside, but you cannot see the clear glass that contains them and gives them their spherical shape. Dark matter is like that invisible glass. It is the silent, transparent architecture of the cosmos, whose presence is only revealed by the beautiful patterns of the stars and galaxies it holds captive. We are therefore living in a universe built by an invisible majority, a silent cosmic ghost that shapes all of reality while remaining completely beyond our senses. Although the cosmos is filled with countless worlds, the precise alchemy that transforms simple stardust into entire planets remains a deeply unsolved mystery. The prevailing theory begins with a young star surrounded by a vast spinning disk of gas and dust. In this cosmic nursery, tiny dust grains, smaller than smoke particles, begin to clump together through gentle collisions, eventually forming pebbles and then kilometer-sized planetesimals. Over millions of years, these larger bodies are thought to pull in more material through their own gravity, slowly building themselves into the planets we see today. However, this tidy picture has a major flaw. As these objects grow to about a meter in size, the surrounding gas should drag them into their parent star long before they can become true planets. The process is like trying to build a colossal sandcastle in a gentle but relentless cosmic wind, starting with only the finest grains of dust. Getting those first grains to stick together and grow into a solid boulder without being swept away into the fire of the central star is a challenge the universe has clearly solved, but we have not. Every planet we discover is therefore a testament to a cosmic construction project whose most crucial blueprints are still missing, hiding the secret of how the universe so readily builds its countless worlds. The very heart of every atom, the proton, is considered to be one of the most stable particles in the universe, but we do not know if it is truly immortal. According to our current understanding of physics, protons should last forever, never breaking down into smaller particles. However, many theories that attempt to unite the fundamental forces of nature predict that protons must eventually decay, albeit on a timescale that is almost impossibly long, trillions of times the current age of the universe. To search for this incredibly rare event, scientists have built massive detectors deep underground, watching vast tanks of water for the telltale flicker of light from a single proton's death. But so far, none have ever been seen. A proton's stability is like that of a great mountain, which to us appears as the very symbol of permanence, solid and unchanging for all of human history. Yet, we know that over immense geological ages, the slow, patient forces of wind and rain will eventually wear that entire mountain down to dust. If protons do decay, it would mean that all the matter in the cosmos, from the mightiest stars to our own bodies, is ultimately temporary, destined to one day dissolve back into a sea of pure energy. Of the four fundamental forces that govern our universe, gravity is by far the most enigmatic, not because of its power, but because of its almost inexplicable weakness. The strong nuclear force binds atoms together, electromagnetism governs light and chemistry, and the weak force controls radioactive decay. These forces are titans of the subatomic world, operating with immense strength over tiny distances. Gravity, on the other hand, is a cosmic giant that shapes the orbits of planets and galaxies, yet at the level of individual particles, it is astonishingly feeble, trillions upon trillions of times weaker than any of its counterparts. This profound weakness is something you can witness in your own home. A simple refrigerator magnet, no bigger than your thumb, can hold a piece of paper against the gravitational pull of the entire planet Earth, a world with a mass of 6 trillion kilograms. This vast chasm in strength, known as the hierarchy problem, has led some to wonder if gravity's true power is diluted, leaking away into hidden extra dimensions we can never see. Vast, invisible magnetic fields thread through entire galaxies and the empty spaces between them, yet their origin is one of the great unsolved mysteries of cosmology. We know these fields are essential, guiding charged particles and helping to shape the structure of galaxies, but we don't know if they started small or were born large. One theory suggests that tiny seed fields were generated by the first stars and black holes, then stretched and amplified over billions of years by the spinning motion of galaxies. The alternative is that these fields were created on a grand scale during the universe's first moments, woven into the fabric of space itself. Trying to solve this cosmic puzzle is like discovering a continent-spanning ancient forest and being unable to determine if it all grew from a handful of tiny scattered seeds that were slowly cultivated over eons, or if the entire landscape was somehow seeded with mature trees from the very beginning. These unseen magnetic rivers flow through the cosmos on a scale we can barely comprehend, a silent and powerful force that sculpted the universe we see today from a past we do not yet understand. In the 1,970 seconds, Stephen Hawking made a breathtaking prediction that black holes, the universe's ultimate prisons, are not entirely black. He theorized that thanks to the strange rules of quantum mechanics, they must slowly leak a faint, steady stream of particles, a phenomenon now known as Hawking radiation. This slow evaporation means that over an unimaginably long time, a black hole will eventually radiate away its entire mass and disappear. This idea is one of the most profound in theoretical physics, as it beautifully unites the laws of gravity, thermodynamics, and quantum mechanics. However, because this radiation is predicted to be incredibly faint, we have never been able to observe it. For a black hole the mass of our Sun, the energy it emits would be far too low to be detected against the cold background of space. It is like trying to hear a single gentle whisper in the middle of a roaring cosmic thunderstorm. Without observational proof, this beautiful and revolutionary idea remains a tantalizing ghost, a prediction that could rewrite our understanding of space and time, but one that we have not yet been able to confirm. In the very first flicker of time, our universe is thought to have undergone an astonishing burst of expansion called inflation, but the specific mechanism that ignited this event remains one of the deepest secrets of creation. In less than a trillionth of a second, a mysterious energy field is believed to have driven space to expand faster than the speed of light, stretching a subatomic speck into a volume vast enough to contain our entire observable cosmos. This single violent event would have perfectly ironed out any initial wrinkles or imperfections, explaining why the universe we see today is so remarkably flat and uniform in all directions. The process is like taking a tiny crumpled piece of silk, no bigger than a single atom, and, in less than the blink of an eye, stretching it out into a perfectly smooth continent-sized sheet, creating the flawless canvas upon which all the galaxies would later be painted. While we can see the breathtaking consequences of this event written across the sky, the true nature of the ghost field that drove it, the spark that lit the cosmic fire, remains completely hidden from our view. The very first stars to ever light up the cosmic darkness, known as Population 3 stars, were born from a recipe that we still do not fully understand. Forged from nothing but the pure hydrogen and helium created in the Big Bang, these primordial suns lacked any of the heavier elements, like carbon or iron, that are common in stars today. These heavier elements act as crucial cooling agents, helping vast clouds of gas to radiate away their heat, collapse under their own gravity, and ignite into stellar furnaces. Without these elements, the first gas clouds would have struggled to cool down, making the process of star birth incredibly difficult and mysterious. The challenge of their formation is like trying to create a rain cloud in an atmosphere that is perfectly spotlessly clean. With no tiny dust particles for water vapor to cling to, it is incredibly difficult for the first raindrops to form and for a downpour to begin. The heavy elements in modern star-forming clouds are like that cosmic dust, giving the gas a way to gather and condense. Solving the puzzle of how these first lonely giants ignited is to understand the moment the universe first lit its own lamps, paving the way for the rich and complex cosmos we see today. One of the most profound cosmological discoveries is that the expansion of our universe is not slowing down but mysteriously speeding up. For decades, astronomers assumed that the initial outward rush from the Big Bang would be gradually tamed by the collective pull of gravity, much like a ball thrown into the air, slows as it rises. However, observations of distant exploding stars revealed a startling truth. The most remote galaxies are receding from us faster than those nearby, proving that some unseen force is pushing the accelerator. This mysterious influence, which we have named dark energy, seems to be a property of space itself, an inherent energy in the vacuum that works against gravity's embrace. It is as if you are watching a loaf of raisin bread rise in an oven, and instead of the rising slowing down as it bakes, the dough suddenly begins to expand, faster and faster, pushing the raisins apart with ever-increasing speed. This cosmic acceleration is arguably the single greatest mystery in all of science, a discovery that reveals our ultimate destiny is being shaped by a force we are only just beginning to perceive. At the most fundamental level, we do not know if the fabric of our universe is a perfectly smooth, continuous sheet, or if it is made of unimaginably tiny, indivisible units. Einstein's theory of general relativity treats space-time as a seamless, flexible medium that can be bent and warped by mass. But in the world of quantum mechanics, everything from energy to matter is quantized, meaning it comes in discrete, pixel-like chunks. Many physicists believe space and time must also follow this rule, suggesting that if you could zoom in to the smallest possible scale, you would find that reality has a fundamental graininess. This is like looking at a high-resolution digital photograph. From a distance, it appears as a perfectly smooth and continuous image, a flawless scene. But if you zoom in far enough, you discover it is actually composed of millions of individual pixels, tiny, distinct squares of color that are the fundamental building blocks of the picture. This single unanswered question about the texture of existence forces us to wonder if our entire universe is built upon a digital foundation, a cosmic screen with a resolution so fine we may never be able to see the pixels. We experience it every moment of our lives, yet one of the most fundamental properties of matter, its inertia, remains a profound mystery. Inertia is the simple, stubborn resistance that all objects have to any change in their state of motion. It is why you feel pushed back into your seat when a car accelerates, and why it takes effort to push a heavy box from a standstill. While Newton's laws perfectly describe how inertia works, they offer no explanation for why it exists in the first place. One intriguing idea, known as Mach's principle, suggests that an object's inertia arises from its gravitational interaction with every other piece of matter in the entire universe, a sort of cosmic consensus that tells it how to behave. It is as if every object is moving through a thick, invisible syrup made of the rest of the cosmos. The resistance you feel when you try to speed up or slow down is the universe itself pushing back against you. This deep and unanswered question reminds us that even the most basic properties of our existence are woven into the fabric of the cosmos in ways we are only just beginning to imagine. One of the most foundational principles we hope is true but cannot prove is that the universe forbids the existence of naked singularities. Normally, a singularity, a point of infinite density where the laws of physics collapse, is found safely hidden at the heart of a black hole, cloaked behind the one-way curtain of an event horizon. This idea that such chaotic and unpredictable points must always be veiled from the rest of the cosmos is known as the cosmic censorship hypothesis, yet it is only a hypothesis. The terrifying alternative is a singularity without a cloak, a point of infinite chaos existing out in the open, visible to the rest of the universe, spewing out effects without causes, and rewriting the rules of reality on a whim. It is as if the universe's most dangerous secrets, the points where its very operating, the system fails, are always locked away in an unbreachable vault. A naked singularity would be that vault door swinging open, exposing the chaotic, code-breaking glitch to the entire cosmos. The search for these objects is a quest to find out if the universe truly plays by its own rules, or if it has left a few of its most terrifying pages open for all to see. One of the deepest conflicts in all of physics lies in a simple question. When a black hole dies, what happens to the information it swallowed? A fundamental rule of quantum mechanics, the bedrock of our understanding of the small, insists that information can never be truly lost. It can only be rearranged. Yet, Stephen Hawking's work on black holes predicts that they slowly evaporate, releasing a faint, random glow of thermal energy that carries no memory of the stars, planets, or matter that fell inside. When the black hole completely vanishes, it seems to take all the unique information about its past with it, erasing it from the universe forever. This paradox is like burning a book. In a normal fire, all the information from the pages is merely scrambled and scattered into the smoke and ash. In theory, you could piece it all back together. But a black hole appears to burn the book and leave behind only a featureless pile of identical ash, with no trace of the original story ever having existed. Solving this profound puzzle is therefore not just about understanding black holes, but about discovering whether the universe truly keeps a perfect, unbreakable record of its own past. Every atom of gold and platinum in our world was born in a cataclysmic cosmic event, yet the exact origin of many of the heaviest elements remains one of the great unsolved mysteries of astrophysics. The universe's initial moments gifted us only the lightest elements, hydrogen and helium. Stars, in their fiery hearts, act as cosmic forges, fusing these into heavier elements like carbon and oxygen, but only up to iron. Beyond this point, creating new elements requires an input of energy, not a release of it. For decades, we believed that the explosive deaths of massive stars, supernovae, were responsible for creating the rest. But recent discoveries have shown that the collision of two incredibly dense neutron stars is also a primary site for this cosmic alchemy. It is as if the universe were a grand cosmic kitchen. The Big Bang provided two basic ingredients, and stars are the ovens for slow baking things up to iron. But the rarest and most precious ingredients, like gold, require a sudden explosive flash of heat and pressure. While we now know that neutron star mergers are a key part of this recipe, we are not yet sure if they alone can account for all the treasures we find, leaving us to wonder what other magnificent and violent events are responsible for seeding the cosmos. One of the deepest and most foundational assumptions in all of science is that the laws of physics are universal, yet we have no fundamental explanation for why this should be true. From the most distant galaxy we can observe to the smallest particle in a laboratory on Earth, the rules of reality seem to be identical. Gravity pulls with the same predictable strength, light travels at the same constant speed, and the atoms of hydrogen behave in the same way billions of light years away as they do inside our own sunday. We observe this cosmic consistency by studying the light from ancient stars, which carries the distinct fingerprints of the elements they contain, and these fingerprints are always the same as the ones we find here at home. It is as if the entire universe is built from a single unchanging strand of cosmic DNA, a fundamental code that dictates the rules for every star, planet, and particle, no matter how far apart they are in space or time. This unexplained uniformity is what makes the science of cosmology possible, but it leaves us to wonder whether this cosmic consistency is a mere coincidence of our particular universe, or a clue to a much deeper principle that commanded all of reality to play by a single set of rules. Contrary to its name, the vacuum of empty space is not truly empty, but instead a seething, energetic sea of activity, and we do not understand the true nature of this energy. According to quantum mechanics, even the most perfect void is filled with virtual particles that constantly pop in and out of existence, borrowing energy from the universe for a fleeting moment before disappearing again. This quantum fizz gives empty space a baseline energy, a zero-point energy, but when physicists try to calculate its strength, their predictions are catastrophically wrong, exceeding what we observe by an astronomical margin. This profound disagreement is one of the greatest unsolved puzzles in modern science. It is like gazing upon the surface of a perfectly still and silent ocean at midnight. It appears to be a sheet of absolute calm, but beneath that placid surface, an entire unseen world of microscopic life is constantly churning. This means that the very foundation of our reality, the nothing that separates the stars, is perhaps the most energetic and mysterious something in the entire cosmos. The greatest single challenge in all of modern science is the quest to reconcile our two most successful theories of reality, general relativity and quantum mechanics. These two magnificent pillars of physics are each perfect in their own domain, yet they are built upon foundations that are fundamentally incompatible. General relativity is the language of the large, describing a smooth, deterministic universe of warped space-time, where the dance of stars and galaxies unfolds with perfect predictability. Quantum mechanics, on the other hand, is the language of the small, a world of discrete pixelated energy and matter, ruled by the strange and unpredictable laws of probability. When we try to apply both theories to the same place, such as the heart of a black hole or the first moment of the Big Bang, their equations clash, producing nonsensical answers. It is as if we have been given two flawless but completely different sets of blueprints for reality. One is a sweeping, elegant architectural drawing of the entire cosmic cathedral, while the other is a hyper-detailed technical schematic of a single brick. Finding a way to merge these two views into a single unified theory of everything would be the crowning achievement of physics, revealing the single beautiful equation that governs all of existence. Our closest celestial companion, the moon, hangs in our night sky as a familiar and constant presence, yet the story of its birth remains one of the most debated mysteries in our cosmic backyard. The leading theory, known as the giant impact hypothesis, paints a picture of unimaginable violence. It suggests that shortly after our planet formed, a Mars-sized object, nicknamed Theia, slammed into the young Earth. This impact would have blasted a colossal amount of molten rock into orbit, which then slowly clumped together under gravity to form the Moon. This idea explains why the Moon has a small iron core and a composition so similar to Earth's outer layers. However, this story has a critical flaw. While we would expect the Moon to be a mix of both Earth and Theia, our analysis of lunar rocks shows its chemical fingerprint is almost identical to Earth's. It's like investigating a collision between a red car and a blue car, only to find the wreckage is made almost entirely of red paint. This profound inconsistency leaves us to gaze up and wonder what extraordinary cosmic ballet set our world on a course to have its own beautiful, ever-present satellite. One of the most profound and everyday mysteries is why time possesses a clear and unwavering direction, an arrow that flies only from the past to the future, never to return. At the most fundamental level, the laws of physics that govern the interactions of individual particles work just as well forwards as they do backwards. A movie of two planets orbiting each other would look perfectly natural in reverse. Yet, in our macroscopic world, this symmetry is broken. The prevailing explanation is the concept of entropy, the idea that systems naturally move from a state of order to disorder. Our universe began in an incredibly low entropy, highly ordered state at the Big Bang, and the arrow of time we experience is simply the universe's relentless journey toward ever-increasing messiness. It is like placing a single perfect drop of ink into a still glass of water. We will always witness it bloom outwards, its ordered shape dissolving into a chaotic, uniform cloud. But we would never expect that cloud to gather itself back into a single drop. Our very perception of a past we remember and a future we anticipate may be nothing more than a consequence of the universe's slow, irreversible slide into chaos. The fabric of space-time, according to Einstein's theories, is a flexible medium, raising the tantalizing but unproven possibility that cosmic tunnels, known as wormholes, could exist. In theory, a wormhole could act as a shortcut, a bridge connecting two incredibly distant points in space, or even two different moments in time. The journey through a wormhole could be like walking across a small bridge that connects two vast, distant continents. Instead of traversing the enormous ocean that lies between them, you simply take a few steps and arrive. However, to keep such a cosmic tunnel open and stable, you would need a form of exotic matter with bizarre properties we have never observed, such as negative mass. All the matter we know of possesses a positive mass and is attractive, pulling things together. But to prop open the throat of a wormhole, you would need something that is gravitationally repulsive, pushing things apart. Without this strange and hypothetical substance, any wormhole would collapse, in an instant, crushing anything inside. The question of whether these cosmic shortcuts are a real and navigable feature of our universe, or merely a beautiful mathematical dream, remains one of the most profound and exciting unknowns. When we map the faint ancient light from the Big Bang, known as the cosmic microwave background, we see a picture of the infant universe that is astonishingly uniform in temperature. However, nestled within this smooth afterglow is a single enormous patch of sky that is mysteriously colder than the rest. This cold spot is not just a minor dip in temperature, it is a vast and statistically improbable anomaly, far larger and colder than the random fluctuations predicted by our standard model of the cosmos. Scientists have considered that it might be the signature of a supervoid, an immense region of space between us and the ancient light that is almost entirely empty of galaxies, which would slightly cool the light passing through it. But even this explanation doesn't fully account for its extreme nature. The CMB is like a perfectly smooth ancient wall, still glowing with the faint, even heat from the moment of its creation. The tiny variations we expect are like faint pinprick-sized smudges, but the cold spot is like finding a single giant ice-cold handprint pressed against it. This unexplained cosmic chill could be the first tantalizing hint of a structure far larger than anything our theories predicted, or perhaps even the ghostly bruise left behind from a collision with another universe. In our everyday world, magnetism is a story of inseparable pairs, yet one of the great lingering mysteries in physics is why we have never found a particle with a single magnetic pole. Every magnet we have ever encountered, from a simple refrigerator magnet to the Earth itself, has both a north and a south pole. If you were to break a bar magnet in half, you would not get a separate north and south piece, but rather two smaller magnets, each with its own distinct pair of poles. And yet, Some of our most elegant and powerful theories that seek to unify the forces of nature predict that these magnetic monopoles should have been created in the fiery chaos of the Big Bang. Their discovery would not only make the laws of electromagnetism perfectly symmetrical, but would also explain why electric charge comes in discrete, fundamental units. The search for a magnetic monopole is like searching the entire world for a coin that has only a head side, with no tails. Every coin we find is two-sided, and if we cut one in half, we simply get two smaller two-sided coins. The profound and continued absence of this single lonely particle leaves us to wonder if our theories are incomplete, or if the universe has simply hidden away one of its most fundamental building blocks. While black holes are famous for their inescapable gravitational pull, many of them somehow manage to launch colossal jets of plasma that travel at nearly the speed of light, and the exact mechanism that powers these cosmic blowtorches is a profound mystery. These jets, which can stretch for thousands of light years, are not fired from within the black hole itself, but from the chaotic, spinning disk of superheated gas that orbits its edge. As this material spirals inward, some of it is violently ejected in two narrow beams along the black hole's axis of rotation. The puzzle is how the immense gravitational energy of the infalling matter is converted into such perfectly focused and powerful outflows. One leading idea is that the black hole's rapidly spinning magnetic fields act like a cosmic slingshot, grabbing onto the ionized gas and flinging it outwards. The entire process is like a spinning garden sprinkler that is somehow also a drain, as water spirals down towards the center. Two impossibly powerful needle-thin jets erupt from the top and bottom, defying the very nature of the drain itself. Understanding how these cosmic engines work is to understand how the universe's most destructive objects can also be its most prolific builders, shaping the growth of entire galaxies with their powerful, invisible hands. Neutron stars are the crushed, city-sized corpses of massive stars, objects so dense that a single teaspoon of their matter would weigh more than all of humanity combined. While we understand the layers of their outer crust, the true nature of their cores, where pressures are beyond anything we can replicate on Earth, remains a complete mystery. At this extreme frontier of physics, our theories predict that protons and neutrons may dissolve into a strange, exotic soup of their fundamental building blocks, quarks and gluons. Some physicists theorize that the core could be a quark-gluon plasma, a state of matter not seen since the first moments after the Big Bang, while others propose the existence of strange matter, a hypothetical and perfectly stable form of quark matter that would make the star incredibly dense. A neutron star's core is like the deepest, most inaccessible point in the entire cosmic ocean, a place where the crushing weight of gravity is so immense that the very atoms we know are squeezed into a new and unknown form of existence. Until we can find a way to peer into these extraordinary cosmic remnants, the heart of a dead star will remain one of the most enigmatic and undiscovered territories in the entire universe. One of the most profound and unsettling questions at the edge of science and philosophy is whether our entire universe, with all its intricate laws and structures, might be nothing more than a highly advanced computer simulation. This idea, while seemingly fantastical, is a serious hypothesis that arises from a simple line of reasoning. If it is possible for a civilization to reach a point where it can create a simulated reality, and if such simulations are computationally cheap to run, then statistically, there would be vastly more simulated universes than real ones. If this is the case, it becomes overwhelmingly probable that our own existence is one of these simulations. From this perspective, the fundamental laws of physics that we strive to uncover might be nothing more than the lines of code that govern our simulated world, and the pixelated nature of reality suggested by quantum mechanics could be the finite resolution of the cosmic computer. It is like being a character in the most sophisticated video game ever created, a game so immersive and complex that you are unaware you are in it, and you believe the game's rules to be the fundamental laws of your own reality. While there is no direct evidence for this idea, it remains a humbling and unprovable possibility that our entire cosmos might be an artificial creation, a beautiful and complex illusion playing out on a hard drive we can never hope to see. We experience our world in 3 distinct spatial dimensions: length, width, and height. Yet the reason for this specific number is one of the most fundamental and unanswered questions about the architecture of reality. Theoretical physics suggests that this is no mere accident. In a universe with only 2 spatial dimensions, the complexity needed for life as we know it could not exist, as intricate biological systems would be impossible to form. In a universe with 4 or more spatial dimensions, the law of gravity would change, making stable orbits for planets around their stars, and even electrons around atoms, an impossibility. Our universe, it seems, exists in a kind of dimensional Goldilocks zone. A universe with too few dimensions is too simple and barren, while one with too many is too chaotic and unstable to last. We are therefore left to wonder if our 3-dimensional home is a rare cosmic treasure, the only kind of stage upon which a story like ours could ever be written. In a vast and silent corner of the cosmos, our own Milky Way galaxy and 100,000 of its neighbours are being drawn toward a mysterious and unseen concentration of mass, a gravitational anomaly we have named the Great Attractor. We can map the motion of these galaxies, and they all seem to be flowing in the same direction, like water heading towards a drain. The problem is that this cosmic mystery lies directly behind the dense, star-filled plane of our own galaxy, a region known as the Zone of Avoidance. This curtain of stars, gas, and dust effectively blinds our telescopes, preventing us from getting a clear view of the immense structure that is exerting such a profound gravitational pull. It is as if our entire local supercluster of galaxies is a vast fleet of ships, all slowly but inexorably drifting toward a single unseen point on the horizon, pulled by a cosmic current whose source is hidden in a thick, impenetrable fog. The Great Attractor is a humbling reminder that even our own cosmic neighbourhood is shaped by powerful, invisible architectures that we are only just beginning to map. Perhaps the most profound mystery that takes place on our own world is the origin of life itself, the unknown moment when a collection of lifeless chemicals first crossed the threshold into a living entity. We know that the young Earth was a chaotic chemical laboratory, with oceans rich in organic molecules, the basic building blocks of life, forged by lightning or delivered by comets. The great unanswered question is how these simple, non-living components spontaneously arrange themselves into the first complex, self-replicating molecule, a kind of genetic sentence that could copy itself and pass on its information. It is like imagining a vast, silent library containing every letter of the alphabet scattered randomly across the floor, and then, without a librarian to guide them, a single, complete, perfectly written, self-copying book suddenly assembles itself out of the chaos. That single, improbable event, which may have happened only once in our planet's history, was the silent starting gun for all of evolution, the humble ancestor of every living thing that has ever graced our world. One of the most elegant and compelling ideas in all of theoretical physics is the theory of supersymmetry, yet it remains a beautiful ghost, a perfect mathematical story for which we have found no physical evidence. The theory proposes that the universe possesses a deep hidden symmetry, suggesting that every fundamental particle we know has an unseen and heavier twin, a superpartner. In this view, every particle of matter, like an electron, has a corresponding force-carrying partner, and every force particle, like a photon of light, has a matter-like partner. The existence of these particles would solve some of the deepest puzzles in physics, providing a natural candidate for dark matter and helping to unify the fundamental forces. It is as if the universe we observe is only one side of a magnificent two-sided coin, and we are living our lives unaware of the perfectly balanced but unseen face on the other side. Yet, despite years of searching in our most powerful particle accelerators, not a single one of these superpartners has ever been found, leaving us to wonder if we are on the cusp of discovering a hidden layer of reality, or if supersymmetry is merely the universe's most beautiful, unwritten poem. In the summer of 1977, a radio telescope in Ohio detected a startlingly strong and unusual signal from the direction of the constellation Sagittarius. The signal, which lasted for just over a minute, was so extraordinary that the astronomer who discovered it circled the printout and wrote a single word in the margin: "Wow!" This powerful narrowband transmission was unlike any known natural cosmic phenomenon, and for a fleeting moment, it seemed to be the perfect candidate for a message from an intelligent extraterrestrial civilization. Yet, in the decades since, despite countless attempts to find it again, the signal has never been repeated. It remains a profound and solitary cosmic mystery, a single unexplained whisper in the vast silent darkness. It is like finding a single, perfectly formed footprint on a vast, untouched beach, only to return the next day to find it has been washed away, with no other signs of a visitor, leaving you to forever wonder if it was a real and deliberate mark, or just a fleeting and random trick of the wind and the waves. The majestic gas giants of our solar system, Jupiter and Saturn, are adorned with beautiful swirling bands of clouds that race across their atmospheres in opposite directions. Yet the deep mechanisms that drive these iconic stripes remain a profound mystery. We know these bands are zones of rising and falling gas, driven by the planet's rapid rotation and the intense heat escaping from their deep interiors. But we do not know how deep these jet streams truly go. Do they extend thousands of kilometers down into the planet, like colossal spinning cylinders, or are they a relatively shallow weather-like phenomenon confined to the upper layers of the atmosphere? The answer to this question would reveal the nature of the engine that powers their dynamic and beautiful surfaces. It is like gazing upon the surface of a vast and turbulent ocean, with its powerful opposing currents and swirling eddies, but having no idea if these features are merely a skin-deep effect, driven by the winds above, or if they are the surface expression of a single mighty river that is flowing thousands of miles below, in the crushing darkness of the abyss. Our small blue world is a watery oasis in the vastness of space, yet the origin of Earth's abundant oceans is one of the most significant and debated mysteries in planetary science. When our planet first formed, it was a scorching molten ball, far too hot to retain any significant amount of water. The leading theory suggests that our water was delivered much later, after the Earth had cooled, by a cosmic bombardment of water-rich asteroids and comets from the outer solar system. In this view, our oceans are the result of countless icy impacts, a slow and steady delivery of the key ingredient for life from the frozen depths of space. It is like finding a beautiful lush garden in the middle of a vast and arid desert, and realizing that every single drop of water that sustains it had to be carried in, one cup at a time, from a distant, hidden spring. This cosmic delivery system would mean that the very water that fills our rivers and rains from our skies is a direct inheritance from the most ancient and distant travelers of our solar system. One of the most subtle yet profound asymmetries in the cosmos is that the universe itself appears to be left-handed. Many fundamental particles possess a quality related to their spin that gives them a kind of handedness, existing in both left and right-handed forms, which are perfect mirror images of each other. And yet, one of the four fundamental forces, the weak force that governs radioactive decay, interacts almost exclusively with left-handed particles. While almost completely ignoring their right-handed twins, it is as if nature itself were a glovemaker who, for some inexplicable reason, decided to produce only left-handed gloves, leaving all the right-handed particles with no way to properly interact with that part of the world. This deep, unexplained preference breaks a fundamental symmetry that physicists expected the universe to obey, a rule that a mirror image version of our cosmos should behave identically. This cosmic imbalance may be a crucial clue, hinting that the very structure of matter and the reason for our existence is fundamentally tied to the universe's mysterious decision to favor one hand over the other. We drift through the cosmos within our home galaxy, the Milky Way, yet one of its most fundamental properties, its true and total mass, remains a profound uncertainty. Our measurements are complicated by the fact that the vast majority of the galaxy's substance is invisible, dark matter, a mysterious material that emits no light at all. We can patiently count the stars and weigh the shimmering clouds of gas and dust we see, but this accounts for only a small fraction of the real total. To estimate the rest, astronomers must painstakingly track the orbits of the most distant stars and ancient star clusters, using their speed to infer the immense gravitational pull of all the unseen matter that holds them captive in their celestial dance. It is like trying to determine the true size of an ancient, continent-spanning forest while standing in a small, moonlit clearing deep within its center. You can see the trees immediately around you and perhaps count the faint campfires flickering at the forest's distant edge, but the true, vast and dark expanse of the woods remains a complete mystery, its immense scale only hinted at by the gentle, unseen influence it has on your small clearing. We are, therefore, residents of a cosmic island whose true dimensions are still a matter of scientific debate, adrift in a structure far grander and more mysterious than we can directly perceive. Type Ia supernovae are the universe's most reliable cosmic yardsticks, yet the precise trigger that ignites these colossal explosions remains one of the most significant unsolved puzzles in astronomy. We know these cataclysms occur when a white dwarf, the dense, burnt-out core of a long-dead star, gains enough mass to push it over a critical limit, triggering a runaway thermonuclear blast. The great debate is how it gets this extra mass. One theory suggests it slowly siphons material from a living companion star, while another proposes a far more violent collision between two white dwarfs. It is as if we have discovered a vast field of identical, exploded pressure cookers, all of which we know burst at precisely the same pressure. But we cannot tell if they each reached that point by being slowly heated over a low flame, or if they were instantly triggered by having a single heavy brick dropped on their lids. Because we have used these uniform explosions to map the entire history of the universe's expansion, understanding the details of their fuse is essential to being certain of our own cosmic story. One of the most baffling paradoxes in our own solar system is the fact that the Sun's outer atmosphere, the corona, is hundreds of times hotter than its visible surface. The glowing surface we see, the photosphere, is a searing 5,500 degrees Celsius, yet the faint, ethereal corona that stretches millions of kilometers into space sizzles at over 1,000,000 degrees. This incredible temperature inversion defies all intuition. It is a mystery that has puzzled solar physicists for decades. The leading theories suggest that the Sun's powerful and tangled magnetic fields act like a giant whip, carrying vast amounts of energy from the interior and violently snapping it into the upper atmosphere, releasing it as heat through a storm of countless tiny explosions. This profound mystery is like standing next to a gentle campfire, feeling its moderate warmth, only to discover that the air 100 feet above the flames is inexplicably hot enough to melt steel. This puzzle serves as a constant reminder that our own star, the familiar heart of our solar system, holds secrets in its wispy crown that challenge our most basic understanding of how energy can behave. One of the most unsettling possibilities in physics is that our entire universe might not be truly stable, but could instead be living on borrowed time in a temporary, metastable state. This startling idea comes from our understanding of the Higgs field, the invisible energy field that permeates all of space and gives fundamental particles their mass. Our cosmos exists in what appears to be a stable energy state of this field, but some calculations suggest this might not be the absolute lowest possible energy level. If a true vacuum with a lower energy state exists, Our universe is currently in a false vacuum, a state that is only temporarily stable. This cosmic arrangement is like a ball resting in a small dip high up on a vast mountainside. While it seems perfectly secure in its little valley, there is a much deeper, more stable valley far below it. A single random quantum fluctuation could, in theory, nudge our universe over the edge, causing it to cascade down to this true ground state. Such an event would trigger a bubble of this new reality to expand at the speed of light, a wave of cosmic change that would instantly and silently erase everything we know. When we map the motion of vast clusters of galaxies, we find something profoundly strange and unexpected, a mysterious, large-scale coherent motion that has been nicknamed dark flow. Beyond the normal expansion of the universe, these immense structures, containing thousands of galaxies, appear to be streaming in the same direction toward a specific patch of sky, travelling at millions of miles per hour. The puzzle is that this shared movement cannot be explained by the gravitational pull of any known superclusters, walls, or filaments within our observable universe. There is simply nothing massive enough in the cosmos that we can see to account for such a powerful and uniform drift. It is as if you were watching a vast fleet of enormous, ancient ships scattered across a calm and gently expanding ocean. You would expect them to slowly drift apart, but instead, you notice that they are all being pulled by a single, powerful and invisible current, a silent cosmic river drawing them toward a destination that lies far beyond the horizon. This unexplained flow could be the first tantalizing evidence of something unimaginably massive and ancient, lurking just beyond the edge of what we can see, a structure from outside our own, observable universe that is still shaping our cosmic destiny. While our telescopes have revealed a galaxy brimming with planets, the actual number of worlds that are truly like our own remains one of the most profound and unanswered questions in astronomy. Our galaxy is now known to be home to billions of planets, with countless worlds orbiting their stars in the so-called habitable zone, that temperate region where liquid water could potentially exist. Yet, being truly Earth-like is a far more demanding set of conditions. It requires not just the right temperature, but also a stable orbit, a protective magnetic field to ward off stellar radiation, a precise chemical recipe for its atmosphere and oceans, and a long, uninterrupted period of cosmic calm for life to take hold and flourish. The search for a true Earth twin is like standing on an infinite beach, knowing that it is made of trillions upon trillions of grains of sand, but having no idea if even one of them is a perfect, tiny, blue-green sphere exactly like the one you hold in your hand. Every new world we discover therefore hangs in a delicate balance between being another hopeful sign of cosmic companionship and a stark reminder of our own magnificent solitude. When we send our robotic explorers out to the far reaches of the solar system, we often use the Earth's own gravity as a powerful slingshot to boost their speed, a maneuver we can calculate with breathtaking precision. Yet on several occasions our spacecraft have emerged from these flyby maneuvers with a tiny, inexplicable anomaly in their velocity, a small but persistent discrepancy that our best understanding of physics cannot explain. All the known forces have been accounted for, from the atmospheric drag to the subtle pressure of sunlight, yet these probes sometimes gain a few extra millimeters per second of speed that seems to come from nowhere. This is like pushing a child on a swing and knowing with perfect certainty how high they should go based on the force of your push, only to watch them swing a single, impossible fraction of an inch higher, time and time again. This subtle cosmic riddle suggests that even within the familiar gravitational embrace of our own homeworld, there are whispers of a new physics we have not yet learned to hear. The black holes we know are born from the death of massive stars, but the universe may be haunted by an older, more mysterious kind, primordial black holes, which, if they exist, are relics from the first second of creation. Unlike their modern cousins, these ancient objects would not have been forged in the collapse of a star. Instead, they would have been born in the chaotic, ultra-dense cauldron of the early universe. In the first moments after the Big Bang, the cosmos was a turbulent sea of energy, and some regions may have become so extraordinarily dense that they spontaneously collapsed under their own immense gravity, forming black holes of all sizes. The formation of these objects is like the difference between charcoal, slowly made from wood, and a perfect diamond, forged instantly in the heart of an ancient planetary-scale explosion. The tantalizing possibility remains that the dark matter holding our own galaxy together is not a new type of particle, but an ancient population of these silent, invisible ghosts from the dawn of time. When we gaze toward the heart of our own Milky Way galaxy, our instruments detect a mysterious and unexplained glow of high-energy gamma rays. This faint, diffuse haze extends for thousands of light-years from the galactic center, an excess of energy that cannot be accounted for by any of the known cosmic sources, such as pulsars or the gas around our central supermassive black hole. One of the most tantalizing explanations for this cosmic fog is that we are finally seeing the faint signature of dark matter itself. Many theories predict that when two dark matter particles collide, they should annihilate each other in a burst of gamma rays. The dense core of our galaxy, with its immense concentration of dark matter, would be the perfect place to see this cosmic signature. It is as if we have been searching for an invisible ghost for decades, unable to see it directly, but we have suddenly noticed a faint, inexplicable warmth emanating from the one room where we are absolutely certain it must be hiding. This gamma-ray glow could be the first indirect glimpse of the unseen substance that makes up the vast majority of our universe. One of the most profound and unsettling observations about our cosmos is that it appears to be exquisitely fine-tuned for the existence of life. The very laws of physics, from the strength of gravity that holds galaxies together to the precise mass of the Higgs boson, are set to values that fall within an incredibly narrow, life-permitting range. If any of these values were altered by even the tiniest fraction, the universe as we know it would have been impossible. Stars would have never ignited, complex atoms like carbon would not be stable, and the entire cosmic story would have ended in a dark, empty, and lifeless void. The situation is like discovering an ancient cosmic radio with dozens of separate dials, each one controlling a fundamental aspect of reality. To hear the beautiful, complex music of existence, every single dial must be tuned to a precise, non-negotiable value. A nudge of one dial just a hair to the left or right, and the result is not just a different song, but an eternity of silent, empty static. This cosmic coincidence forces us to wonder if our universe is the result of an unimaginable cosmic lottery, one of countless other silent universes, or if it is a sign of a deeper, undiscovered principle that made a universe like ours inevitable. The vast and beautiful cosmos we can see, stretching for billions of light years in every direction, is known as the observable universe, yet we have no way of knowing what lies beyond its distant horizons. Because the universe is only about 14 billion years old, the light from any object more distant than that has simply not had enough time to reach us. This cosmic speed limit creates a sphere of knowledge around us, an observational bubble beyond which the rest of reality, which may be infinite, remains completely hidden from our view. It is as if we are standing on a small, well-lit island in the middle of a vast, dark and uncharted ocean. We can see and explore every inch of our island with perfect clarity, but we have absolutely no way of knowing if the ocean that surrounds us extends for another 100 miles, or if it stretches on for an eternity, filled with countless other islands just like our own. The tantalizing and humbling possibility remains that the entire cosmic story we have pieced together is just the first introductory sentence in a cosmic book whose true length and grandeur we can never hope to know. On the grandest of all scales, our universe is not a random scattering of galaxies, but is instead arranged in an immense and beautiful structure known as the cosmic web. This intricate network is made of vast, shimmering filaments of dark matter and gas that stretch for hundreds of millions of light years, connecting massive galaxy clusters at their intersections, while being separated by enormous, dark, and empty voids. Yet the true nature of this vast, invisible skeleton of the cosmos remains a deep mystery. We are still trying to understand how the faint, wispy gas that traces these filaments is heated and magnetized, and how it flows along these cosmic highways to feed the growth of the galaxies that are embedded within it. It is as if we have just discovered that all the cities on our planet are not randomly placed, but are instead connected by a vast, continent-spanning network of invisible roads, and we are only now beginning to see the faint outlines of the traffic that has been flowing along them. For all of time, this beautiful cosmic structure is the grandest architecture in the universe, a silent testament to the simple laws of gravity acting on a cosmic scale. Our entire understanding of the cosmos is built upon just 4 fundamental forces, but there is a tantalizing possibility that the universe is governed by other, hidden forces that we have not yet discovered. We know of gravity, which orchestrates the dance of planets and stars, electromagnetism, which governs light and chemistry, and the strong and weak nuclear forces, which rule the subatomic world. Together, these 4 forces form the standard model of particle physics, a theory of breathtaking success. And yet, this beautiful model is profoundly incomplete. It offers no explanation for the mysterious dark matter that holds our galaxies together, nor the enigmatic dark energy that is pushing the universe apart. These vast cosmic puzzles are like shadows being cast by an object we cannot see, hinting at a deeper, more complex reality. Our current understanding is like listening to a grand celestial symphony and being able to clearly hear only 4 sections of the orchestra: the strings, the brass, the woodwinds, and the percussion. We can appreciate their beautiful and intricate music, but we can also sense a deep underlying rhythm and a powerful haunting melody that cannot be accounted for by the instruments we recognize. It is as if a 5th invisible section of the orchestra is playing, its music resonating on a frequency our ears cannot yet perceive, but its influence shaping the entire cosmic performance. The search for these new forces is therefore a quest to finally hear the full hidden music of the cosmos, to understand the silent conductors that have been shaping our universe from the very beginning. Orbiting the vast halo of our Milky Way are hundreds of globular clusters, breathtakingly beautiful, spherical swarms containing hundreds of thousands of ancient stars. Yet how these dense, glittering cities of stars formed remains a profound cosmic mystery. These clusters are like celestial fossils, containing some of the very first stars to ignite in the universe. We know this because their stars are all incredibly old and lack the heavy elements that are forged in later stellar generations. This suggests that each cluster was born in a single magnificent burst of star formation that occurred over 14 billion years ago. The puzzle is how such an immense cloud of primordial gas could have collapsed and converted itself into so many stars with such astonishing efficiency, all before the first supernova explosions from the most massive stars could blow the remaining gas away. It is like finding thousands of perfectly formed, identical glass beads that were all somehow created in the heart of a single violent firework explosion. The very force that should have scattered the raw materials seems to have instead perfectly and simultaneously crafted them into a dense, sparkling swarm. These beautiful stellar relics are therefore time capsules from the dawn of the universe, whose very existence points to a lost and incredibly powerful mode of starbirth that has since vanished from the cosmos. One of the most significant crises in modern cosmology is that we cannot agree on a single, precise number for the expansion rate of our universe, a value known as the Hubble constant. This number tells us how fast the cosmos is stretching apart, and we have 2 incredibly precise ways to measure it that give 2 stubbornly different answers. One method looks at the faint afterglow of the Big Bang, the ancient light from the infant universe, and uses our best theories to predict how fast the universe should be expanding today. The other method measures the distances to nearby stars and exploding supernovae to see how fast the modern universe is actually expanding right now. The situation is like having a perfect photograph of a child on their second birthday and a flawless growth chart that should predict their adult height with absolute certainty. But when you go to measure the adult today with a perfect tape measure, you find they are several inches taller than the prediction allows. Both measurements are exquisitely precise, yet one of them, or the theory that connects them, must be fundamentally wrong. This quiet but persistent cosmic disagreement, known as the Hubble tension, could be the first whisper of a new and undiscovered physics, a sign that our grand story of the universe is still missing a crucial chapter. The magnificent rings that adorn our gas giants, like Saturn's iconic crown, are cosmic jewels whose origins remain a beautiful and unsolved mystery. We do not know if these glittering, icy disks are ancient relics or recent creations. One possibility is that they are primordial, the leftover material from the giant clouds of gas and dust that first formed the planets, a cosmic nursery of debris that was too close to the planet to ever coalesce into a proper moon. The alternative, more violent theory suggests they are the stunning remains of a moon, comet, or asteroid that strayed too close and was torn apart by the planet's immense gravitational forces. It is like finding a breathtakingly intricate and perfectly arranged necklace of glittering diamonds, but being unable to tell if it was meticulously crafted from a pile of leftover stardust or if it is the beautiful, shimmering ghost of a single magnificent diamond that was shattered in a forgotten cosmic collision. This cosmic uncertainty leaves us to wonder if we are witnessing the final glittering embers of a world's creation or the beautiful fleeting memorial to its destruction. The cosmos is filled with stars of unimaginable size, yet there appears to be an invisible ceiling on their growth, a cosmic limit that we do not fully understand. A star's entire life is a delicate balancing act between the inward crush of its own gravity and the furious outward push of the light and heat generated in its core. As a star grows more massive, this outward radiation pressure becomes incredibly intense, a constant ferocious wind of pure energy. Our current theories predict that beyond a certain point, this stellar wind becomes so powerful that it physically blasts away any new material that tries to fall onto the star, setting a natural and violent limit on its size. This cosmic balancing act is like trying to blow a bubble from the thinnest and most delicate of soaps. For a time, the fragile surface tension of the soap film can contain the pressure of your breath as the bubble grows. But there is a point of no return, a moment when the outward push becomes too great for the film to hold, and with a sudden, beautiful burst, the bubble can grow no more. This mysterious and violent ceiling on stellar growth therefore defines the upper limit of the universe's great lighthouses, dictating the maximum brightness and power of the cosmic engines that seed the heavens with the elements of life. As humanity begins its slow but inevitable expansion into the cosmos, we are stepping into a profound evolutionary mystery, for we have no idea how the strange new pressures of space will reshape our species over the generations. For millions of years, our bodies have been exquisitely adapted to the specific conditions of Earth, from its gravity and atmosphere to its magnetic field that shields us from cosmic radiation. In space, these rules are rewritten. The near-weightless environment will alter our bones and muscles, while the constant exposure to high-energy particles could introduce new mutations into our DNA. Our future colonies on the Moon, Mars, or in deep space habitats will be like isolated islands in the vast cosmic ocean. Just as unique species of birds and tortoises evolved in the isolated environment of the Galapagos Islands, each human outpost, separated by the immense and unforgiving sea of space, could become its own distinct cradle of evolution. The great journey outward may therefore be a journey inward, a path that could ultimately fork the river of human evolution, creating new branches of humanity as different from us as we are to the ancestors who first looked up at the stars. Our planet's long history is a story of dramatic and rhythmic climate swings, with vast ice ages that come and go like a slow, deep breath. Yet the full reason for this planetary pulse remains a deep and complex mystery. We have identified the celestial pacemaker of these great winters, subtle, clockwork-like variations in Earth's orbit, tilt, and wobble, known as Milankovitch cycles. These gentle shifts slightly alter the amount of sunlight reaching the poles over tens of thousands of years, nudging our world's climate. The problem is that these orbital changes are far too subtle on their own to account for the dramatic plunge into global glaciation. The orbital changes are like a child giving a gentle rhythmic push to an enormous heavy swing. The push itself is far too weak to account for the great height the swing eventually reaches. There must be a hidden, powerful amplifier within the Earth's own systems, perhaps involving ocean currents or greenhouse gases, that takes this tiny nudge and turns it into a monumental shift. Our planet, therefore, possesses a deep and powerful climate heartbeat, one that is paced by the quiet music of the heavens, but is driven by a powerful internal rhythm we have not yet learned to fully hear. Among the strangest and most hostile places in the entire cosmos are pulsars, the rapidly spinning hyperdense remnants of exploded stars, yet against all odds, we have found planets orbiting these violent cosmic corpses. These pulsar planets are bathed in a relentless torrent of lethal radiation, lashed by a stellar wind of unimaginable intensity, making them some of the most inhospitable worlds imaginable. The profound mystery is not just how life could possibly exist in such a place, but how a planet could even come to be there in the first place. Any original planets would have been vaporized in the supernova explosion that created the pulsar, meaning these strange new worlds must be cosmic survivors or second-generation planets, formed from the dusty, chaotic debris left behind by the star's cataclysmic death. It is like finding a delicate, perfectly formed bird's nest with unhatched eggs built in the heart of a raging permanent forest fire. The sheer impossibility of its existence forces us to reconsider our most basic ideas about where and how the universe can build its worlds, reminding us that even in the most violent and desolate corners of the cosmos, the patient and creative process of planetary formation can find a way. One of the deepest and most unsettling questions in all of science is the profound and echoing silence from the cosmos, a mystery known as the Fermi paradox. Our galaxy is home to billions of potentially habitable Earth-like planets, many of which are billions of years older than our own. Statistically, it seems almost inevitable that intelligent technological civilizations should have arisen countless times in our galaxy's long history. Some of these civilizations would have had a vast head start on us, ample time to develop technologies for interstellar communication and travel, and to spread their presence across the stars. And yet, when we listen to the heavens, we hear nothing. We see no grand engineering projects, no interstellar superhighways, no evidence of any cosmic companions at all. It is as if we have woken up in the middle of a vast and ancient city, a metropolis with 1 trillion silent houses, and found that we are the only ones awake. The possible solutions to this paradox range from the hopeful to the terrifying, suggesting that we are either the very first, a rare and precious cosmic anomaly, or that some unseen and universal danger awaits every civilization that dares to reach for the stars. Our own sun, the familiar heart of our solar system, undergoes a dramatic personality change on a regular basis, with its entire global magnetic field completely flipping upside down, and the deep inner workings of this reversal remain a profound mystery. Roughly every 11 years, the Sun's magnetic North Pole becomes its South Pole, and vice versa, in an event that marks the peak of its turbulent activity cycle. We know this process is driven by the Sun's solar dynamo, a complex engine powered by the flow of superheated, electrically charged gas within its interior. Because the Sun spins faster at its equator than at its poles, the magnetic field lines are dragged and stretched, becoming twisted and tangled over time like threads in a giant chaotic loom. The entire process is like taking a giant invisible rubber band that runs from the sun's north pole to its south pole and slowly twisting it at the middle. As the twists become tighter and more tangled, the band stores immense energy, and eventually the entire structure becomes so unstable that it snaps and reconfigures itself into a new reversed orientation. This grand solar reset is the fundamental engine that drives the cycle of sunspots, solar flares, and coronal mass ejections that ripple across our entire solar system. A constant reminder that our star's serene appearance hides a powerful and cyclical magnetic heart whose rhythm we have yet to fully comprehend. In the cosmos, there exists a type of explosion known as a kilonova, a cataclysmic event whose brilliant but fleeting light holds the secret to how the universe creates its most precious treasures, yet its true nature remains a profound puzzle. We believe these events are born from the most violent of cosmic collisions, the final, desperate, in-spiral and merger of two city-sized, hyperdense neutron stars. In that cataclysmic instant, a vast cloud of neutron-rich material is flung into space, a perfect crucible for the creation of the heaviest elements in the universe. The event is like a celestial blacksmith's forge of unimaginable power. The collision is the violent, universe-shaking strike of a hammer, and the cloud of ejected material is the glowing, exotic metal on the anvil. In a fraction of a second, the universe rains down a torrent of cosmic neutrons upon this metal, instantly transforming it from a simple iron-like substance into a glittering spray of the rarest elements. Like gold and platinum, every piece of gold on our world is therefore the shimmering, ancient ghost of a cataclysm that briefly outshone entire galaxies, a silent testament to the universe's most violent and creative alchemy. In the cosmic menagerie of strange and wondrous objects, there is a theoretical entity that is the perfect, time-reversed opposite of a black hole, an object known as a white hole, yet we have no idea if they are real. Where a black hole is an inescapable cosmic prison, a region of space-time from which nothing can ever leave, a white hole would be an uncontrollable cosmic fountain, a region from which matter and energy would erupt, but into which nothing could ever enter. Mathematically, they are a valid solution to the equations of general relativity, but physicists have long suspected they are a mere mathematical ghost, a beautiful but physically impossible solution, like a perfect frictionless machine that can never be built in the real world. However, some have speculated that the very creation of a black hole might give birth to a white hole in another place or time, or even that the Big Bang itself was a kind of white hole, the ultimate cosmic gusher from which our entire universe sprang forth. The search for these objects is therefore a quest to find the universe's ultimate giver, a place of spontaneous and uncontrollable creation, the perfect and beautiful opposite of its most famous and insatiable taker. The Higgs boson is the particle that gives all other fundamental particles their mass, and cosmic inflation is the event that set the stage for our entire universe. Yet the relationship between these two cosmic titans remains a profound and tantalizing mystery. The Higgs field, the invisible energy field that permeates all of space, is what makes the Higgs boson possible, and many physicists believe that this very same field, or a close cousin of it, might also be the inflaton, the mysterious hypothetical field that drove the universe's explosive, faster-than-light expansion in its first moments. This beautiful and elegant idea would unite two of the most fundamental concepts in all of cosmology, suggesting that the very same field that gives a feather its tiny mass is also responsible for the grand architecture of the entire cosmos. It would be like discovering that the gentle, barely perceptible breeze you feel on a calm summer's day is actually the localized echo of the same impossibly powerful hurricane that first carved all the continents and oceans on your world. The possibility remains that the answer to one of the greatest mysteries in cosmology, the origin of the Big Bang, has been quietly whispering to us all along through the subtle and ubiquitous presence of mass itself. Our galaxy is not just home to stars and the planets that faithfully orbit them, but is also thought to be haunted by a vast, unseen population of rogue planets, lonely worlds that drift through the interstellar darkness, unbound to any star. Yet the origins and properties of these cosmic orphans remain a deep mystery. We believe there could be billions or even trillions of these solitary wanderers in the Milky Way alone. Some may have been violently ejected from their home systems during the chaotic early days of planetary formation, flung into the void by the gravitational billiards of their larger siblings. Others may have been born alone, from the direct collapse of small, dense knots of gas and dust, too small to ever ignite into a true star. A rogue planet is like a lone, forgotten ship drifting silently on an endless dark ocean, its sails torn and its crew long gone. It follows no set course, guided only by the gentle, collective currents of the cosmic sea. These dark worlds are therefore a silent testament to the chaotic and violent history of our galaxy, a hidden population of lost children that may outnumber the stars themselves. When we gaze out at the cosmos on the largest possible scales, we see a universe that appears remarkably still and serene, with no overall sense of cosmic rotation. Yet the reason for this profound stillness remains a deep and unanswered question. If the universe as a whole were spinning, we would see its signature imprinted on the faint ancient afterglow of the Big Bang, a subtle spiral pattern in its temperature that would tell us our cosmos has a preferred direction. But our best observations show no such cosmic swirl, a fact that our standard model of cosmology simply assumes but does not explain. The early universe was a chaotic and turbulent sea of energy, so it seems almost inevitable that it should have possessed some initial random spin, just as water swirling down a drain naturally develops a vortex. It is as if we are observing a vast cosmic-scale explosion that, against all odds, expanded with perfect, breathtaking symmetry in all directions, with not a hint of a twist or a turn. This profound lack of rotation suggests that the universe may have begun with an even more perfect and mysterious degree of order than we can currently explain, a silent testament to the deep, hidden symmetries that governed the moment of creation. Many of the universe's most beautiful spiral galaxies, including our own Milky Way, are distinguished by a vast, luminous bar of stars that bisects their glowing core. Yet the exact process of how these colossal structures form and then govern their galactic homes remains a deep cosmic mystery. The leading idea is that these bars are born from a subtle gravitational instability within the galaxy's spinning stellar disk. Over millions of years, the collective pull of billions of stars can cause their orbits to stretch and align, spontaneously organizing them into a vast, rotating river of suns that is far more than just a static feature. This process is like watching a vast, shallow whirlpool form in a gently spinning basin of water. A small, random disturbance can grow and organize the chaotic flow into a powerful, stable vortex that begins to funnel everything towards its center. These celestial bars may therefore be the great engines of galactic evolution, the immense and silent conduits that connect the serene outer arms to the hungry, star-forming heart of the galaxy. In the cold, dark and distant reaches of our own solar system, far beyond the orbit of Neptune, there is a growing and tantalizing body of evidence for the existence of a huge, undiscovered world, a hypothetical Planet 9, yet its nature and even its existence remain a profound mystery. The clue to its presence lies in the strange, improbable orbits of a handful of small, icy bodies in the Kuiper Belt. These distant objects all seem to be clustered together, their orbits tilted and aligned in the same direction, as if they are all being shepherded by the unseen gravitational hand of a single, massive planet. The gravitational signature of this hidden world is like a set of deep, parallel footprints you might find on a vast, untouched, snowy plain. You cannot see the great unseen animal that made them, but the sheer size and perfect alignment of its tracks tell you not only that it exists, but also something of its immense scale and the direction it is traveling. If it is real, this distant, ghostly world would reshape our entire understanding of our cosmic backyard, a silent, frozen giant that has been hiding in plain sight for billions of years. Our understanding of how stars live and die is one of the cornerstones of modern astrophysics. Yet there is a growing and unsettling possibility that our beautiful and intricate models of stellar evolution may be fundamentally incomplete. These models, built upon our best understanding of nuclear physics and thermodynamics, have been breathtakingly successful at explaining the life cycles of the vast majority of stars. And yet, when we look at certain ancient star clusters or try to precisely model the interior of our own sun, our theories show subtle but persistent cracks. We have trouble explaining the unexpected abundances of certain elements, and our predictions for a star's brightness or size do not always perfectly match our observations. It is as if we have written a magnificent and sweeping biography of a great historical figure, a story that perfectly captures the broad strokes of their life, from their birth to their dramatic death. But when we look closer at the fine details, at the daily entries in their personal diary, we find small but persistent inconsistencies, moments and details that do not quite fit the grand narrative we have so carefully constructed. These subtle cosmic discrepancies remind us that even the most familiar and seemingly well-understood actors on the cosmic stage may still be hiding some of their deepest secrets. Beyond the orbit of Neptune lies the Kuiper Belt, a vast and icy debris field that is home to countless frozen worlds. Yet the strange and improbable orbits of many of these distant objects remain one of the most significant and unsolved puzzles in our solar system. Instead of the flat, predictable paths we would expect, many of these icy bodies are on wildly tilted, elongated and clustered orbits, as if they have been stirred and sculpted by an unseen gravitational force. The leading explanation for this cosmic choreography is the NICE model, a theory that proposes our entire solar system underwent a period of violent and chaotic instability in its youth. In this dramatic story, the giant planets Jupiter, Saturn, Uranus, and Neptune migrated from their original, more compact orbits, scattering the smaller, icy bodies of the early solar system like cosmic bowling pins. This grand planetary reshuffling is like a single violent earthquake that suddenly and permanently rearranged the entire geography of a once orderly continent, leaving behind a jumbled and chaotic landscape of mountains and valleys where there were once only flat plains. The strange orbits we see today are therefore the ancient frozen echoes of a time when our own cosmic backyard was a far more violent and unpredictable place. Perhaps the ultimate ambition in all of science is the dream of a single elegant theory that could explain the entire universe, a final theory of everything, yet this grand prize remains tantalizingly out of reach. This ultimate goal is to find a single set of mathematical rules that can unite our two most successful, yet profoundly incompatible descriptions of reality. We have general relativity, Einstein's beautiful theory of the large, which describes the graceful dance of planets and galaxies. And we have quantum mechanics, the strange and powerful theory of the small which governs the chaotic world of subatomic particles. When we try to use them together, in places like the heart of a black hole, their equations break down, creating a deep and unbridgeable chasm in our understanding. It is as if we have discovered the universe is a grand and beautiful symphony, and we have found two perfect, but separate, pieces of its sheet music. One score describes the soaring, majestic melody of the cosmic strings, while the other describes the sharp, rhythmic beat of the quantum drums. Both are flawless on their own, but they are written in different keys and follow different tempos, and when played together, they produce only a chaotic noise instead of the single, unified harmony we know must exist. The search for this final theory is therefore the search for the universe's master score, a single, beautiful line of music that would allow us to finally read the complete and unified mind of the cosmos. The vast, dark, and seemingly empty spaces between the galaxies are not truly empty but are instead filled with a faint, tenuous, and almost invisible substance known as the intergalactic medium. Yet the nature of this cosmic ocean remains one of the least understood components of our universe. This incredibly diffuse sea of gas, containing most of the ordinary matter in the cosmos, is the vast reservoir from which all galaxies are born, and the cosmic recycling plant into which they expel the elements forged in their stellar hearts. We are only just beginning to learn how this cosmic web of gas is heated by the intense radiation from quasars, how it is enriched with heavy elements by the explosive winds of ancient supernovae, and how it flows along the great, dark filaments of the cosmos to feed the growth of the galaxies. It is as if we have spent our entire lives studying the beautiful glittering islands that dot a vast and dark ocean, but we have only just begun to invent the tools we need to understand the immense, deep, and life-giving waters that connect them all. This invisible medium is therefore the true, beating heart of the cosmic ecosystem, a silent and transparent sea whose currents have shaped the entire history of the universe. As a species, we have learned to create new and exotic elements that nature itself cannot, yet the ultimate cosmic fate of these artificial creations remains a profound and unanswered question. In our most powerful particle accelerators, we have forged super-heavy elements, fleeting and unstable behemoths that exist for only a fraction of a second before decaying back into more familiar forms of matter. Some theories predict, however, that there may exist an island of stability, a region of the periodic table where super-heavy elements could be incredibly long-lived, lasting for thousands or even millions of years. If we could one day create such an element, we would have forged a new and enduring form of matter, a human-made substance that could outlast our cities, our continents, and perhaps even our species itself. It would be like a lonely and mortal artisan who has spent their entire life working with simple clay and wood, suddenly discovering the secret to forging a single immortal diamond, a perfect and enduring jewel that would carry the quiet echo of their existence into the deep cosmic future, long after the artisan and their workshop have turned to dust. The quest to create these new elements is therefore not just a journey to the limits of physics, but a quiet and perhaps eternal whisper into the void. Our planet is constantly being bombarded by ghostly particles called neutrinos, and while most of these are relatively low-energy travelers from our own sun, a few of them are ultra-high-energy cosmic messengers, and we have no idea what is launching them across the universe. These ethereal particles, which can pass through an entire planet without leaving a trace, carry millions of times more energy than those produced in our most powerful particle accelerators. To create such a particle requires an astrophysical engine of unimaginable power, some of the most violent and extreme events the universe has to offer. The leading candidates are the supermassive black holes that lurk at the hearts of active galaxies, which are thought to act as colossal cosmic accelerators, flinging these particles out at nearly the speed of light. The journey of these particles is like a single perfect arrow, shot from a bow of unimaginable power, that flies in a perfectly straight line across the entire cosmic ocean, unimpeded by the magnetic fields that bend other cosmic rays. Each time we detect one of these ghostly travelers, we are therefore receiving a direct and pristine message from the heart of a cosmic cataclysm, a single, whispered clue to the location of the universe's most powerful and mysterious engines. In the grand quest to unite all the forces of nature into a single elegant theory, one of the most promising but unproven contenders is known as M-theory. Yet its true nature and validity remain a profound mystery. M-theory is not a single complete idea, but rather a mysterious and overarching framework that seems to unite all 5 of the consistent versions of string theory, which themselves propose that the universe is made of tiny, vibrating strings. This beautiful and enigmatic theory suggests that our universe is not a 3-dimensional stage, but is instead a vast, 11-dimensional cosmos. In this view, Our entire reality is a brain, a vast three-dimensional membrane floating within this higher dimensional space, and the other fundamental particles are like strings whose ends are tied to this brain. It is as if our entire universe, with all its stars and galaxies, is like the shimmering two-dimensional surface of a vast and deep cosmic pond. We can perceive the ripples and waves that travel along the surface, but we are completely unaware of the true hidden depth of the water that lies just beneath our reality. M-theory is therefore not just a candidate for the final theory, but a profound and humbling suggestion that our entire perception of the cosmos may be just a single, beautiful shadow of a much grander and forever hidden reality. In the grand cosmic tapestry of galaxies, there are not only vast shimmering filaments of light, but also immense and terrifying deserts of almost perfect emptiness, and the largest of these, the Boötes Void, presents a profound and unsettling mystery. This colossal, nearly spherical region of space, sometimes called the Great Nothing, is almost 330 million light-years in diameter, a volume so vast it should contain thousands of galaxies, yet we have found only a few dozen. The existence of such an immense and empty chasm in the cosmic web is a challenge to our standard models of how the universe evolved. These theories predict that gravity should have woven a far more uniform and interconnected structure without such a gaping and improbable hole. Staring into the Boötes Void is like looking at a vast continent-spanning forest and finding in its very heart a perfectly circular and unnaturally empty plain, a place where the trees simply refuse to grow. This profound and silent emptiness could be the result of a chance, random fluctuation in the distribution of matter, or it could be the ghostly ancient scar left behind by the collision of smaller, bubble voids, a silent testament to a far more complex and violent cosmic history than we can currently explain. The beautiful, sweeping arms of a spiral galaxy appear as though they are permanent, majestic structures, yet how they maintain their elegant shape for billions of years is one of the most profound and unsolved puzzles in astrophysics. A galaxy does not rotate like a solid spinning record, the stars closer to the center orbit much faster than those in the outer regions. If the spiral arms were made of a fixed collection of stars, this differential rotation would quickly stretch and wind them up into a tight, unrecognizable blur in just a few 100 million years. The leading theory suggests that these arms are not structures at all, but rather density waves, slow-moving ripples of higher gravity that sweep through the galactic disk. It is like a cosmic traffic jam on a vast celestial highway. The individual stars are the cars, which are constantly moving through the jam, slowing down as they enter the dense region and speeding up again as they leave. The cars themselves are always in motion, but the traffic jam itself, the pattern of congestion, maintains its shape and moves slowly along the road. These majestic arms are therefore not places at all, but beautiful shimmering events, grand cosmic patterns that sweep through the galaxy, triggering brilliant bursts of starbirth wherever they pass. At the North Pole of Saturn, there exists one of the most bizarre and beautiful weather systems in our entire solar system, a colossal, hexagon-shaped jet stream, a storm so vast that 4 Earths could fit inside it, yet the origin of its perfect and improbable geometry remains a profound mystery. No other planet in our solar system has anything like it. For decades, scientists have tried to replicate this stunning natural wonder in computer simulations and laboratory experiments, attempting to understand what forces could cause a swirling, turbulent fluid to spontaneously organize itself into such a stable and six-sided pattern. The most promising ideas suggest that the hexagon is the result of a standing wave pattern, a kind of cosmic resonance that forms at a specific latitude in Saturn's atmosphere. It is as if you were to strike a vast planet-sized drum, and instead of a chaotic cacophony of sound, it produced a single, perfect, and unwavering musical note, a geometric vibration that holds its shape for centuries. This beautiful and enigmatic storm is therefore a silent testament to the incredible and often counterintuitive elegance of the laws of physics, a perfect and otherworldly jewel that has been hiding in plain sight in our own cosmic backyard. The speed of light in a vacuum is the universe's ultimate and unbreakable speed limit, a fundamental constant of nature that underpins all of modern physics. Yet the question of whether we could ever find a way to travel faster than light remains a tantalizing and profound mystery. Einstein's theory of special relativity makes it clear that as an object with mass approaches the speed of light, the energy required to accelerate it further increases exponentially, becoming infinite at the limit. This means that no ship, no matter how powerful, could ever break through this cosmic barrier. However, this does not forbid the possibility of a cosmic shortcut. Some theoretical ideas, like the Alcubierre drive, propose that we could travel faster than light, not by moving through space, but by warping the fabric of space itself, creating a bubble of space-time that would expand behind our ship and contract in front of it. It would be like a surfer riding a powerful, self-generated wave on the cosmic ocean. The surfer themselves is not moving through the water at an impossible speed, but the wave they are on is carrying them forward faster than a swimmer could ever hope to go. While this remains a beautiful and purely theoretical dream, requiring a form of exotic, negative energy we have never seen, it reminds us that the vast, empty distances between the stars may not be as unconquerable as they appear. A black hole is the universe's ultimate point of no return, a place where gravity is so strong that nothing can escape. Yet the final state of the matter that falls into one remains one of the most profound and unanswered questions in all of physics. Einstein's theory of general relativity predicts that all the matter from a collapsed star, or any unfortunate object that crosses the event horizon, is crushed into a singularity, a point of zero volume and infinite density where the laws of physics as we know them completely break down. This idea, however, is a profound and uncomfortable one for physicists, as nature seems to abhor the concept of a true infinity. It is as if we are reading a grand and beautiful story, a book that describes the entire cosmic narrative with breathtaking elegance and precision, only to find that the very last page contains a single, incomprehensible, and untranslatable word, a point where the language of the universe itself ceases to have any meaning. The search for a theory of quantum gravity is therefore a quest to write that final page, to find a new and deeper language that can finally tell us what truly happens in the silent, hidden heart of the cosmos. Our planet is teeming with life, yet the origin of its most fundamental building blocks, the amino acids that form the basis of all proteins, remains one of the most significant and unsolved mysteries in the story of our existence. We do not know if these crucial ingredients for life were born here on Earth, or if they were delivered from the stars. The early Earth was a chaotic and energetic place, a primordial soup of simple chemicals where lightning and volcanic activity could have provided the spark to forge these complex molecules. However, we have also found these very same amino acids and even more complex organic compounds inside meteorites that have fallen to Earth. This tantalizing discovery suggests that the raw ingredients for life are not unique to our world, but are instead common throughout the cosmos, forged in the cold, dark clouds of interstellar space and delivered to young planets like ours by a constant rain of comets and asteroids. It is as if we have found a beautiful and thriving garden, but we cannot tell if its seeds were native to the soil or if they were carried in on a gentle, cosmic wind from a garden that is as old and as vast as the universe itself. Our universe is not just a stage for matter and energy, but is also a vast cosmic computer, a system that is constantly processing information, yet the ultimate limits of its computational power remain a deep and unanswered question. Every time two particles interact, every time a star is born or a galaxy collides, the universe is performing a kind of calculation, its state changing from one moment to the next, according to a strict set of physical laws. Some physicists, like Seth Lloyd, have even attempted to estimate the total computational capacity of the observable universe, treating every particle as a tiny bit of information in a vast quantum computer. The profound and unanswered question is whether this cosmic computation is finite or infinite. Does the universe have a limited memory and processing speed, or is it a machine of boundless potential? It is as if we are living inside the most powerful and complex computer imaginable, and while we can see its breathtaking output all around us, from the swirling of a galaxy to the beating of our own hearts, we have no way of knowing the true nature of its hardware, or if there is a fundamental limit to the cosmic code it can run. As our journey through the cosmic unknown comes to a gentle close, let the vastness of these mysteries settle around you. Tonight, we've drifted through the great unanswered questions, from the invisible scaffolds of dark matter to the silent, echoing question of life beyond our world. We've wondered about the very fabric of space-time, the dawn of the first stars, and the ultimate fate that awaits us all in the deep, cosmic future. These puzzles are not a sign of our limits, but an invitation to wonder, a reminder that we are a small but profoundly curious part of a story that is still being written. The universe's greatest secrets are a gentle lullaby, a soft whisper that there is always more to discover. And now, as the cosmos continues its silent, mysterious dance, may you find your own peaceful rest in the quiet darkness. Sleep well.